welcome. This time I want to explain about categorial embedding. Categorial embedding is a technique that used for a neural network. So this is used to encode categorial data like this. So here first I want to introduce the dataset here. Let's run this. Okay, here we have a meteorological dataset. So we have a location. This location is a IQ code for the airport, and then month, time, wind speed, visibility, etc. And in this dataset, the location, time, and flow total here is the string column. So basically, this three column is categorial data, right? So when we handle a categorial data, usually we will use one hot encoding. So one hot encoding is like, let's see, okay. For example, here in the location, we have I already calculate this. We have a 16 combination, and then basically, if we include the location for our computation in neural network, we will have a 16 addition of input neuron. Addition of 16 input neuron, I think it's overkill. Why not we just to get rid of that, like, like PCA, because we have many, we use PCA because we have many input neuron, right? So category embedding here, it's basically, I think it's same. We get rid many, yeah, we transform the dataset to decrease the input neuron. Okay, so how it works is basically like this. For example, for the location, this is the input neuron addition. If we include the location, okay, suppose we have 16 here. And then we will transform this 16 input neuron to, for example, let's see, we will have a 2 neuron. So it will be like this, right? Basically, it will be like, and then, in our dataset, we have a column like wind speed, visibility, temperature. That is numerical data, right? So their place will be in here. Because this is temperature, this is TD, and this is rate or humidity. So yeah, we will find a weird-looking neural network in here. And this is the output neuron. Okay, here. So basically, we will usually in the neural network, the input neuron, all the input neuron will begin in here, right? So, but if we using the category embedding, we must transform this addition input neuron here that is one hot encoding to this, to here. For example, to the 2 neuron. So the first task is transform them, and then after that, yeah, the operation of input neuron. And then after that, the neuron, and then the last is the output neuron. And to make you more understand about this, sorry, This is the code for the model here. This is the code for the model here. And if you using Python in this code, I'm using Python. To do that, we will use this embedding layer. And here, the numlock here is the, for example, oh yeah, in this code, the time column here, I encode this time column using one-hot encoding. So yeah, I do the embedding, categorical embedding too for this time column. And then this location. So basically, the numlock here is the total addition neuron that if we do one-hot encoding, and we transform that to this embedded size lock, that is basically we transform them to 2 and to 3. Here for the location, I encode that to 2, and for the time, I encode that to the 3. This is the forward operation. So here, as you can see here, we do embedding operation first, and after that, we concatenated them to the rest of the input neuron. Here, this is the continuous input. This is for the visibility, temperature, TD, cloud height. And then after that, we doing the usual operation, usual dense operation like here, like that. And yeah, this is the final, the output neuron. We doing a softmax because we want to, in this case, we want to predict the weather. Yeah, in this video, I just want to explain about how do this category embedding. But in reality, when I run this model, the result is pretty bad. Also, the use case of this categorical embedding is used that we combine the transfer learning and this categorical embedding.